Welcome to Chapter 2 of our video series on creating REST services with OpenEdge. In this chapter, you're going to see how you can create data object services and expose them with a REST interface. In our introduction, we showed you some of the things that you might use REST services for. This chapter is going to focus on building REST services that make it easier to interface with modern web applications built with tools like Kendo UI, interfacing with native mobile apps using tools like Progress Convey or Progress NativeScript, and other emerging technologies coming from Progress and other providers. We call these data object services. They are the easiest type of REST service to build in OpenEdge. Data object services provide a prescriptive REST interface that will accelerate UI development. Their primary drawback is that they provide the least flexibility in how the REST API may be called. When you create data object services, you will typically choose to create a data object catalog. This is a JSON file that describes the public interface to the service. In fact, this data object catalog is sometimes referred to as a JSON catalog. It allows us to use an open-source client-side technology invented by Progress called the JavaScript Data Object, or JSDO. You can think of JSDO as client-side pro datasets. If you create data object services and use the JSON catalog, many Progress technologies will seamlessly integrate with your OpenEdge application code. We're going to start this chapter by creating a new project in Developer Studio to hold our services. With Developer Studio running, in the server perspective, see if PassOE is running. You can tell this by looking for the words started synchronized, as you see here. If it doesn't say this, start PassOE by right-clicking on it and selecting Start. Once the app server is up and running, you should see Started Synchronized. Create a new project by right-clicking in the Project Explorer area and choosing New, OpenEdge Project. This will start the Project Create wizard. Enter the project name as Data OBJ SVC, as you see here. Use the default location to save the project. Choose the server box on the left because this will be a server-side project. Select Pass for OpenEdge as the application server. Select Web as the transport, as this is the easiest and most flexible transport when using Pass for OE. Check the Create a Data Object Service box so that it will generate a JSDO catalog. Click Next to continue the creation of the project. On this screen, make sure that the Deploy as Web App and OE Pass 1 boxes are checked, and click Next. We're going to change the service name to DOS. Also notice the sample URI on this screen. This shows us how we will access services that we create in this project. Click Next. Click Next on the Select AVM and Layout Options screen without making any changes. On the ProPath screen, click the Add Workspace Directory button. We're going to add the Conference API project to our ProPath so that we can call code in it when we customize our services in later exercises. Open the Conference API selection, choose Source, and click OK. Click Move Up until this new path is at the top of our ProPath. This will make this project the first place that is looked in when our services are looking for custom code to run. Click Next. We're going to add a connection to the conf database to our project. Click the Show All button at the top of the screen, and then check the database called conf. Once it's selected, click Finish. After a short time, you'll see a new project appear under the Project Explorer. This is where we're going to create our services and automatically deploy them to PassOE. We are now ready to begin creating REST services. The first service that we'll create will be a service that exposes create, read, update, and delete, or CRUD operations against a database table. In the Project Explorer, inside of our service, right-click on the App Server folder, choose New, and select Business Entity. This is a wizard that will walk us through the creation of a data object service. Next to the business entity name, type Speaker BE, as you see here. Leave all other fields unchanged and click Next. Select CRUD next to Operations and make sure that Write Data Set Before Image is checked. We'll talk about this option when we start testing our services. Next, click on Select Database Table and then choose the speaker table and click Finish. Now if you look in the App Server folder in the project, you'll see that two new files have been created. SpeakerBE.cls, which was opened for you, is the new OO-ABL class that was created automatically. This defines the operations for this service. If you look at the methods for this class, you will see the operations that will be called when this service is invoked: create, delete, read, and update. If we look at the create operation, for example, you will see a call to super. This means that when you call this method, a new record will be created using the JSON body that you send in your REST call. We're going to do this in just a minute. You can customize this behavior by calling your abl.p files from inside this method. We'll see an example of that later in this chapter. The speaker.i file is an include that defines the pro data set that will be the interface to this service. When your REST service call interacts with the SpeakerBE class, it will expect and return all or part of this pro data set in a JSON formatted message body. Congratulations! You just created your first RESTful service using business entities in OpenEdge. Next, you will deploy this service to the PaaS-OE server so that you can access it from a REST call. To deploy this service, click on the plus next to Define Services in the Project Explorer pane. Double-click on DOS to see the Edit an ABL Service screen. Leave this screen unchanged and click Next. Since we will be deploying the new SpeakerBE service to PaaS-OE, check the box next to SpeakerBE.cls to select it if it isn't already checked. Notice here at the bottom of the screen that there is also a sample URL. This is how we will call this service when we test. Once the class has been selected, click Finish. Since we told PaaS-OE to automatically publish, after a brief time, OE Pass 1 in the Servers tab will once again show Started Synchronized. After that, we're ready to test. The easiest way to test the service is to use the Chrome browser. Enter the URL that you see here and press Enter. What you will see is a JSON object representing the speaker table. Because there are no records in the database, you'll see this response. The JSON displays for me in this easy-to-read format because I installed the JSON Viewer plugin in Chrome that we talked about in Chapter 1. In the introduction, we talked about the data object catalog that would be created. If you're interested in seeing this, you can enter this URL. This is the catalog that is read by services using JSDO in order to manage the interaction between the client, like an app built with Kendo UI, and the service. The other way we can test the operations on our service is to use a REST testing tool. Using the Insomnia application that we installed in Chapter 1, we can test different operations of our new service. If you decided to use Insomnia as we do in this series, you'll need to import a project that contains all of the different calls. Choose the top left box. In my case, it says Next Conference API, and then choose Import Export. Click Import Data, and choose from File. Go to your download directory, where we downloaded from GitHub, and navigate to Conference API Master /conf. Choose conferenceapi.json and click Import. You will see a message that the import succeeded and click OK. As a side note, if you see no environment in the area right below where you selected Import, click on the pull-down and choose Use Conference Instance. Expand the Mobile Connect section and select Read Speakers. Click the Query tab, and you'll see that the URL is the same as we entered in Chrome. Click Send in the upper panel, and it will call the service with a GET verb. The response will appear in the right-hand panel. This will be the same response that we got when we tested with Chrome. This means that calling our service URL with GET will retrieve the records in the table. Now click the Create Speaker item in the left list. Click on the JSON tab to see a sample of the payload that needs to be sent to the same URL with a POST operation instead of a GET in order to insert a record. If you like, modify the data in the sample to include your name and bio, and then click Send. The result will appear in the right panel. Now go back and choose Read Speakers again and click Send, and you'll see that the response includes the new record that we just added. Use the Create Speaker operation again to create another speaker record with ABL-013 as the ID using a different name and bio. Read Speakers will now show you that you have two records. Notice that you can also delete and update speakers using the same URL by changing the post to a delete or a put. Here, we will delete a speaker with the ID of ABL-013. When we do this delete, the response is very interesting. Remember, we checked a box that said Write Dataset Before Image. We were telling the JSDO to send back the new record along with its original values in the response when we execute the operation. Here you can see that the deleted part is the record before the delete and the resulting record which has just been deleted. We can also update a record by using put. Just make the changes in the JSON you send and it will update the record in the database. When you execute this operation, you'll see again that the record before the changes is returned along with the new record after the changes. Again, the reason this is happening is because we checked the Write Dataset Before Image box when we created this service. Take some time and try different things with get, post, delete, and put verbs. When you're comfortable, you can move on. As we wrap up Chapter 2, let's recap what we talked about in this lesson. We created a server-side project for building a data object handler service in Developer Studio. We created a business entity CRUD service against a database table. We deployed the service to PaaS-OE. And we tested the service using Chrome and Insomnia. In our next chapter, we're going to learn how to create a CRUD service against a pro dataset instead of a database table. Then we're going to learn how to customize our service to call an external.p. And we'll do more service testing.